Take a moment and look at this small, unassuming spacecraft. Voyager 1 weighs just 722 kilograms, about the same as a small car, yet it has already traveled farther than any human-made object in history. As of April 2026, it is more than 24.3 billion kilometers away from Earth. That's 162 times the distance between the Earth and the Sun. If you tried to drive a car at highway speed non-stop toward Voyager 1, it would take you over 30,000 years to reach it. And yet, this tiny probe is still sending back faint whispers of data across that unimaginable distance. The question everyone eventually asks is this: how far can Voyager 1 actually go? Will it ever reach another star? Will it drift forever? Or will it simply run out of power, become a silent frozen relic floating in the void for billions of years? And long-term cosmic reality of what lies ahead for humanity's farthest messenger. Let's start at the beginning. Voyager 1 launched on September 5, 1977, just weeks after its twin, Voyager 2. Both were designed for a 4-year mission to study Jupiter and Saturn, but they exceeded every expectation. Voyager 1 used gravity assists from Jupiter and Saturn to slingshot itself out of the solar system at high speed. In 1990, it took the now famous pale blue dot photograph, that tiny speck of light that showed Earth as a single pixel suspended in the vastness of space. Since then, Voyager 1 has been on an interstellar journey. In 2012, it became the first human-made object to cross into interstellar space, the region between the stars where the sun's influence ends and the true void begins. As of today, it is traveling at about 17 kilometers per second relative to the sun, roughly 61,000 kilometers per hour. That sounds fast, but on the scale of interstellar space, it's actually quite slow. At this speed, it would take Voyager 1 roughly 80,000 years to reach the nearest star system, Proxima Centauri, which is 4.2 light-years away. But here's the catch: it's not even heading toward Proxima Centauri. It's traveling in a completely different direction, roughly toward the constellation Ophiuchus. Hi. Sorry for interrupting, I just have a quick update for you all. You know how something crazy is always happening in space? New planets, strange anomalies, and space missions launching all over the world? That's exactly why we have started a weekly space newsletter called CosmicGazeYT that brings you the most exciting space updates every week. The first issue is completely free on my Patreon, so you can go read it right now. If you enjoy it, you can upgrade to get a new issue every week there and stay up to date with everything happening in space. And you can even join our private chat there to discuss it all together. The link is in the description, so do check it out. And hey, if you don't want to spend money right now, no issues, I'll see you in the YouTube comments. Thank you so much for watching my content. Back to the video now. It's traveling in a completely different direction, roughly toward the constellation Ophiuchus. The nearest star in that general direction is more than 17 light-years away. At its current speed, it would take over 300,000 years just to get there. In cosmic terms, it's barely moving at all. So no, Voyager 1 is never going to reach another star system in any meaningful time frame. But distance isn't the real limiting factor anyway. The real limiting factor is power. Voyager 1 is powered by 3 radioisotope thermoelectric generators, RTGs, that convert heat from decaying plutonium-238 into electricity. Every year, the power output drops by about 4 watts. Right now, it's producing just enough electricity to run a few instruments and send a very weak signal back to Earth. A signal so faint that it arrives with less power than a watch battery. Engineers have been carefully managing power for years. They've already shut down heaters, turned off non-essential systems, and prioritized the most important instruments. They predict that by 2030 to 2032, Voyager 1 will no longer have enough power to run its science instruments. By around 2035 to 2040, it will likely lose the ability to communicate with Earth entirely. After that, it becomes a silent, dead spacecraft, still moving through space, but no longer talking to us. After communication ends, the real journey begins. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of the star Gliese 445. To put that into perspective, 1.6 light-years is still incredibly far, about 40 times the distance to our nearest star, Proxima Centauri. Even when Voyager 1 makes its closest approach to another star, it will still be farther away from that star than the Oort cloud is from our sun. It will never actually enter any star system. It will simply keep drifting through the darkness alone. In roughly 300,000 years, it will come within about 4 light-years of another star. It will simply keep drifting. In about 5 billion years, our sun will expand into a red giant, swallow the inner planets, and eventually shrink into a white dwarf. By that time, Voyager 1 will still be out there, a tiny frozen relic carrying the golden record, a message from a long-dead civilization. And in about 6 billion years, the Milky Way and Andromeda galaxies will begin their slow collision. The stars will pass each other like ships in the night, but Voyager 1 will still be drifting through the chaos, now part of whatever new galactic structure forms. The spacecraft itself is remarkably durable. Space is mostly empty, so the chance of it hitting anything significant is extremely low. It could theoretically survive for tens of billions of years, longer than the current age of the universe. But eventually, even the golden record will erode. Micrometeoroid impacts over billions of years will slowly wear it down. The information it carries will fade into silence. That golden record is one of the most beautiful things humanity has ever sent into space. It contains 27 pieces of music from around the world, 55 greetings in different languages, sounds of Earth, waves, birds, laughter, a kiss, and even a message from then President Jimmy Carter. It was designed to last for 1 billion years or more. If another civilization ever finds Voyager 1, they will receive a time capsule from a small, watery planet that once existed in a quiet corner of the Milky Way. They might play the golden record. They might hear our music, our voices, our laughter. They might wonder who we were. And for one brief moment in cosmic time, a small part of humanity will still be speaking across the stars. It's a humbling thought. If this journey into Voyager 1's incredibly long future moved you, then consider hitting the like button, subscribing to CosmicGazeYT, and turning on the notification bell. We've got a whole universe of space and more possible theories left to explore, and I'd love for you to join me on the next adventure. Thanks for watching, and I'll see you in the next one.